So in the last video, we maybe unzipped the file, we explored it, we pre-processed it, and we uploaded our final maybe images to which were converted to record IO. The extension was .rec. This was the extension. So what we did, uh, we have we have done all of this process. Okay, so everything is inside record.io folder over here. Okay, so now what is up next now? So first what I will do, we have only unzipped the file, I guess, on this. So what I am trying to do is I am trying to maybe rename it so that that will be easy for you to maybe follow along. Okay, so what we have done, we have unzipped the file, we have explored and the pre-processing image. Okay, so this is not pre-processing. We have only downloaded image dot rec image to rec, we can say script, which is converting our images to record.io format. Okay, so let's do one thing. I will put this up to here only. Okay, this is the first thing which we did, and after that I have to rename this thing, and again I'll put it one, but I will give it name of pre-processing uploading images. Two can write here to S3. Okay, now maybe you can relate uh, in a better way. Okay, so that's the thing. Then I have to give it maybe two. That will work fine, I guess. Okay, so that's the thing. I would have done it in the backgrounds, but again, just to make sure that you will understand everything, because as this project will increase, uh, I'm telling you, it will become a lot more complex to understand. Okay, so what from here you have to do is, we have saved the record.io files, which are maybe required by MXNet, which we can use the inbuilt version in Sagemaker. So then for for using built-in algorithms, we have to first configure the algorithm using the using we can say AWS SDK for Python. Okay. So what I will do, I will first take one new notebook, and maybe I will choose one kernel from here that will be called the MXNet, maybe MXNet latest 3.6. Let's go with Conda MXNet 36. Okay, just I'm taking one more maybe notebook, and I will rename it with maybe what we are doing is we are configuring the we can say algorithm. Okay, we are configuring it to use maybe uh, this low level AWS SDK for Python. Okay, so what I can write is how to relate it. Okay, I can say configuring using low level, you can say AWS Python SDK. This is nothing but development toolkit. Okay, SDK and that tool, Python SDK. Okay. So just I have clicked on the name. So first thing here, what I will zoom it a bit. Okay. So first thing will be to configure images. To configure built-in images for maybe classification. algorithm inside SageMaker. Okay. So SageMaker we know, so I'm not writing it. So we are configuring built-in image classification algorithm. Okay. And using what we are using for this configuration. For this configuration, we are using low-level AWS SDK for Python. Okay. And what kernel we are using? The kernel we are using is Conda MXNet P36. We need not to maybe uh, bother about MXNet now. This is pre-installed. Okay. So I will import some of the important libraries. Okay. Just import time, import Boto 3. Why Boto 3? So it is a Python client for AWS and SageMaker. Okay. So and SageMaker and Python libraries. Okay. So basically this is a Python client. Okay. So from SageMaker I have to take get execution role, and from again from SageMaker dot Amazon Amazon estimators estimators. I have to take the estimators, and from there I have to import uh, get image URIs. Okay, so that's the thing. Let's run it and see if there is some error, or maybe we are going fine or not. Okay. So no module name Sagemaker. Sagemaker. Okay. So executed fine. So let's create some of the variable. So what I am doing is I will not write it from now. Okay, it is taking much time. So what I am doing is I am creating some variables for configuring hyperparameters. Okay. So some variable will be number of classes. So as this is maybe there will be two classes, cancer or no cancer, 0 or 1. So number of classes will be 2. Then I will say number of training samples, and that will be maybe how much training sample we can have. That is 14 615. Now you might be thinking how I got this number. So you have to go to home. Okay, go to home, and inside here uh, for maybe test train. Okay, images train.lst. Go inside it, and here maybe see how many rows are there. So there are, maybe I will put it down. I will go to the footers, and there are 14617 rows. Okay, so that's the that number of rows are there, 14617. Okay, so this is how I came to this 14615 point. Okay, and oh sorry, 14, that must be, I guess, yes, 17. Yeah. Then number of layers, you can say number of layers, and we will take maybe three number of layers, and then mini batch size. You need not to, what I am telling you is you need not to maybe mm, get into all this code. Okay, because the main aim, don't forget the main aim. The main aim is to maybe understand what will be like what is the flow, how to work with the SageMaker. Okay, and how it is helping us. Okay, so that's the main aim. So you need to understand the flow so that you can use this flow and these code for other maybe for other use cases. Okay. So the image shape is 350 by 50. This is the image shape, and this is the channel. And after that, maybe I will go for augmentation. You might be thinking, what is the use of augmentation? Yeah, augmentation type. you might be thinking, what is the use of augmentation? I'm cropping it. Crop, color transform. Okay, you might be thinking, what is the use of augmentation? So come over here, home. Now you can see image train LST. Okay, so these are the number of again these are the number of training images. Okay, so we are having, I showed you, maybe I will show you again just to make sure you will understand the concept. So there are 14617 training images, and I will cross it. This also training images. Then I will go to images test LST and see there is a big class difference between 1 and 0 images. Okay, so we are having cancerous images, we are having less. The images which are having cancer in them, they are very less, and the images which don't have cancer in them, they are very they are their count is much. Okay, so if I'll go to cancer detection images, then uh, if I'll try to show you from here, 14662 items for 0, and for 1 we are having only 3610 items. Okay, so there is certainly a class imbalance. So what I will do, we will do augmentation, and we will crop the color transform, so that it will help maybe to upgrade some of the images. Okay, so basically it will what it will do, it will maybe work with that class well imbalance. Okay, and it will balance the classes. Then we have epochs, that is 3. Then we have learning rate, and maybe learning rate will be 0.02 or maybe 0.1. And then are we using pre-trained model? uh yeah, so we use pre-trained model equals 1. Equal 1 means we I am enabling transfer learning. Okay, so pre-trained model 1, that is yes, transfer learning can be used. So I am running it too. So no worries. We have uh, uh, so here what I can say is we are performing image augmentation. Okay, so why? Because we have imbalanced data set, and maybe image augmentation will help us to work with it. Okay, and how to maybe get these all hyperparameters, or you must be thinking how I am knowing uh, all these hyperparameters do exist. Okay, so if you are really curious, or if you want to know that, so you need to simply go to one of the links that will be maybe